Audio check. 1, 2, 3. Sounds good to me. All right, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. Today, we are on compiler day, which is nice. It's a nice break from everything else. We've been working hard on the game, getting real close to wrapped up. We're going to do one more chalk doodad, a little method for switching between the chalk doodads, and then what? Some last minute bug fixes, a couple of optimizations on size of the program, and yeah, it's basically marketing from there. So I did some work after hours, but we can talk about that next week. So this is all the wrong project. So let's kill that and bring up a new Emacs buffer, Emacs window. Get it sized for streaming. And what we're working on today is the compiler. So get up our journal, our to-do list. Okay. Okay. So we barely had enough time last week to generate a tokenizer for our project files and our tokenizer definition files. It's not been tested or put together yet, so why don't we bring up a shell, make sure we're all checked in, make sure that our latest commit was at least entered in somewhere. If we fall too far behind, it just becomes a big pain in the neck to dig this back up. So let's just save it real quick. Week 21. The date was, well, it'll be today, 2024. The hash we found for the end of last week is this one, 1206. Grab our hash. We did not record the time. Let me grab that time real quick. Last week, the compiler was 6:16:56. 6:16:56. One of the nice things about recording and stream is I know exactly how long I worked on a project. So we'll just stub this out for today. Okay. Okay. Am I missing anything? Not really. I think we're good. So, to do, let's crank up today's documentation. 1206. Tasks for the day. And it'll be a short stream today, so sorry about that, but you know, I have things to do. So today, generate tokenizer for project file and test. Let's see here. Project file. Let's see here. VB project file. Generate a tokenizer. Test the tokenizer. We'll stub something out somewhere. Come in Tokenizer in VV project. And we'll basically do the same thing. VV Tokenizer definition file. We're going to generate a tokenizer for it. We'll test it. Then we'll plumb it in VV Tokenizer definition. That's our plan. I got a bill in about 4 hours, so like I said, short stream, but we're on the go here. And this is one of those times where things start getting a little bit weird and meta. We're writing config files and code, which compiles, which outputs. We're writing code, which reads in a configuration that writes out code that compiles to read in a file that we use to generate the next generation of tokenizers. So this will be fun. We'll see how far down this road we get. So last time we looked at VV project. And what we're going to say is this is actually ASCII. But our tokenizer can't be, and I haven't decided what to do there. Because we have, unfortunately, 4 different versions of our string handling. Let me just show what I'm talking about. Assets, code, snippets. We have a character reference, which points to a place in a buffer, and we have that supported for ASCII. We have it supported for Latin 1 encoding, and we have it supported for UTF-8. However, in our actual project, we have a character reference, and it can switch between the 3 encodings. So we can set the encoding and unset the encoding. This is the magic sauce that we right now don't get. Oh, this might be more painful than I wanted. Set default encoding. Is this a road we want to go down? We don't have to right away, but it's something that's in the back of my mind. We may have to support multiple encodings in our tokenizer, which makes me a little sad. Okay, well, we'll let that sit in the back of our minds. Meanwhile, we have this thing. And it says we're only doing ASCII and use this tokenizer definition file, which is vvp vtokenizer. So we support new line characters. We support white space. A comment will be a double // name, encoding, tokenizer definition, parser definition. Encoding is one of ASCII, Latin, or UTF-8. And for now, our file path is not very sophisticated. We may have to also allow a colon / underscore minus a through z 0 through none. Yep. Log period / colon underscore. I guess that's it. And we add a rule in make file, which was what? My tokenizers. Okay. I'm not sure that needs to be there. We haven't touched that. Why is that even there? I don't think we need this file. Remove ASCII. See if that breaks anything. What else we got here? Dun 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 dun. VV project parser. Those are the should be two files. Oh, because CPP. Yeah, so we got both these files. So we need a simple way to test. Okay. We'll need a test string. We can get a whole bunch of test strings if we want to. Blah, blah, blah. Log defines. That actually has been very nice. So we'll steal that. Actually says what flags we built it with. We don't need those or the test. That's it. Okay. Test execution. We start with a context. I really should, since we've done the testing at this point, write the wrapper bits. Elpsy Kangaroo. Heyo. How did the space doodad go yesterday? It's pretty awesome. Title of the stream is a mouthful. Yeah. Yeah, let's go take a look at where we ended up yesterday. We can do that real quick. I did a little bit of art cleanup work this morning. I still got to do the rings, but here it is. Planets go around, the stars twinkle, and our rocket ship flies. Woohoo! So there you go. That's a space doodad for you. Like I said, we've still got to clean up the artwork around the rings a little bit on Saturn and Uranus, but overall, not bad. Whee! So there you go. Nice. Nice space doodad. Thanks. Just one more little thing for people to interact with. So I'm going to call that one a success for now. I think we need to make things like Neptune even slower. Like that 1 minute, it's not very long. But anyway, a little bit of cleanup work left on the rings, but pretty good. Yeah, next week we'll grow some plants, I think. And that'll be the last of the doodads. Make the sun of gravity well. So you're using negative z values for the ordering. I remember you said you were using sine cosine functions. Yeah, so let's see here. I guess it depends on the space. I do x is horizontal and y is vertical when I'm talking screen space, which we're in a 2D game, so that's what I'm using. So I'm using the y value for their ordering. So basically, the higher up the chalkboard you are, the further back you are. Yeah, make the sun a gravity well and blow up the rocket. That would be amusing. That would be amusing, but I've already got an archer that kills himself, so we can't do the same trick every time. Yep, I already have a decent number of doodads. Yeah, we've got 4 solid ones. I think one more and call it good. Then we'll make it so we can switch between them. Be able to switch between the doodads. So if you want to, put them away or bring one out because you're thinking, that's possible. That's the plan next week. We'll finish off the doodads. Last of the doodads next week. So yeah, looking pretty good. Looking pretty good. So we set the context. After we do that, it depends on whether we're lazy or batch processing. If we're batch processing, we process. We're just going to log the tokens actually. So let's see here. That's actually something we do in context.tokens. Oh, I guess we can do this. Okay, so we batch process, we slam the process, we count out errors. All right, and now, good. You have a good time? We're doing, we're going to do good things on the compiler today. Doing fun things. You have a good one. If we have errors, all right, warning count. I guess we'll put in a blank line after errors and warnings if we feel like it. Push tokens. For every token, log it, and then do the thing. Okay. So that's it, batch process. This one will be a little different. Well, it has a token, we get the token. And I guess we log our errors and warnings after we finish. It's a little bit fun. Okay. We don't have token size yet. Okay, what is the tokens? Okay. So no matter how we build this, it should just run. This thing, we need a valid test string. So we look at VVP, or if we look at VV project, V tokenizer rules, lines, white spaces, and comment. So we should be able to start with a comment. Comment check. We want to do this. Keyword. So we need name, coding. Syntax right now is very minimal. Let's just do colon. Project. Coding. ASCII. No. Syntax encoding. File path. So this is the toke depth. That's what I wanted. So this is going to be vvp.vtoke. New line done. We should this thing just make sure it's working. Okay. So test one. No matter how we build this. Hey, Suki, how's it going? How is it going? You got your text rendering yesterday, if I remember right. That's always nice. That's text rendering is shockingly hard. I actually, well, hard. There are lots and lots of gotchas and corner cases that are surprised me. But now that I've done it once, I know what I want to do next time. Okay, I think that's everything I want to do here. There's a lot of tokenizer or tokenizing in the title. Yep. The thing that actually killed me in text rendering was not word wrapping, but trying to wrap long words. So like word wrapping wasn't too bad. You just count backwards to the space and you move the quads over to the new place, and it's a pain, but it's not bad. If you have a really long word that you want to split with like a hyphen to go across lines, that killed me. I actually took that back out. It was so bad. So when you use a good text layout program that does that, that's that was killing me. Although I think I have a better way to do it now. I think I'm going to do in the future. I'm going to make a plain text and a rich text. And my rich text is not going to be anything like how other people do their rich text. So we'll see how that goes. But that's future. That's future work. All right. So in our make file, when we build these tokenizers, we're going to, let's see here, test, build. Compiler base flags, debug flags, depend defines, VB project parser -C. And then we'll do this one, compiler base flags, debug flags. We're not going to do that. Test underscore proj log VB project parser. We'll try that. We'll comment that up for now. We'll come back to that. Compile. Clean my tokenizers. Let's just see how that goes. Yep, doing good, doing good. You can look at the Discord. You'll see the current progress of the RTS. Ooh, fun. Oh, fun. Discord, fun. Programming, excellent. Suki, I'm doing a region-based rendering for a European map. Okay. Okay. Yeah, this is your World War One. Yes. Okay. Cool. No, never mind. Cool. Nice. Good progress. Everything is in JSON. Well, I will say JSON has its place. JSON has its place. It's easy, right? That's the reason to use it. It's easy to get started using it. Test proj. I have some mistakes. Okay, there's one. Pop. Let's see here. So don't waste much time hard coding everything in C++. Also, it makes it so I don't have to compile every time. Yep. Yeah, if you're making a game that has any kind of customization, you definitely want some file format and a level editor and all that stuff. Array test one initialized by parenthesized string literal. I don't see any problem with that. That seems fine to me. Oh, okay. Forgot about those. There we go. That should fix some of the issues. Okay, pretty close. Array test one initialized. Yeah, that's a tokens. That's right, because we did it. Equals context.tokens. That's what we want. There we go. Should just be the warning. I don't know why it doesn't like parenthesized string literals. That's not very nice. What if we unparenthesize them? I guess that's better. All right, well, whatever. testproj.cpp. Whatever. Okay. So in theory, that gives us the source builds debug db project. Doesn't? Did we overwrite our own file? db project parser builds debug. Source db project parser. There's an .o file. Source builds debug db proj parser. There it is. Okay. Switch batch bind iterator functions open. So we got. So this is what we're tokenizing. Is test proj. This is the text. We got 9 tokens. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, looks like it worked. So we get name colon thing, encoding colon thing, token definition colon thing. Perfect. So that's the initial test. The comments are gone, then line numbering is correct. So line 1, line 2, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4. Character 10, I probably believe that. I believe they're all 10 because we line them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Yeah. So everything's working so far. Looking good. Let's see here. So I don't have to compile every time. Modding, yes, support for modding is huge, which is quite good for a C++ game. Yeah, it makes it possible to create completely custom maps. Yep, and custom AI. Oh, the AI will be JSON. Interesting. Okay. I also think I'll make the GUI in a JSON also, so the game would be super easy to configure. Nice. Those are all very laudable goals. I approve. Yeah, so what you're doing is basically called data-driven design, right? You're going to design some data, and then you're running the engine that interprets that data, basically. So when you say custom AI, you're going to have probably triggers and actions and events, right? And those are things that you can specify in a data file or hard-coded data, whatever. But then the engine cranes through that, and it uses that data to make decisions. A great example of this, I think it was, which one was it? Was it Halo? They basically said, what are all the variables that ever define a weapon, period. And so they had, fire rate and ammunition and distance and power, and is it a ray or is it a bullet, or all, so like it was tons of it. And they basically used all of it. And they're like, okay, so here is one engine that models a weapon, period. Everything else is just this array of values to define what the weapon behaves like. And then, the image. And what that meant they could do is they could play with weapon types really fast. And that's why they had such interesting weapons. And again, like you said, for the modders just pick different parameters and give it a different graphic, and they got a whole new behavior for a weapon that hadn't been created before. So it's super cool. But that kind of design uh, can be very difficult to pull off well. It means people can do what they want without much limitation, which is pretty cool. Makes it user friendly for users to commit to the game. It's all they need to modify is the high level interface, which is JSON. Yep, probably the only. Yeah, so the closed source part of the game is the part that interprets the JSON. That makes sense. That's actually not a bad way to build it out. I like that. Good plan, good plan. All right, so we are tokenizing our project file. And I'm going to take a short break here for a restroom break. And then we'll pick up with that. We'll continue the progress. Okay. All right, let's see here. The whole code will be open source. Okay, I said the code, not the resources. Yeah. Basically, I want you to make a paid game that's open source, but you can build the game for free and play it also. Nice. So see, the more technical people probably just do a build themselves and play it, but lacking some features like auto updates and official resources. Or for the more casual player, probably pay the $3 to $5 to play the game or go to the Pirate Bay. Yeah, I don't know. For sure, but at that point, just compile the game yourself and install very legally the JSONs. Because without the data, you can't use anything. Yep. Interesting. Cool. Sounds like fun. Well, good progress. You're showing things on the screen, text is rendering. Very nice. Okay, so we are tokenizing our project file. Okay. But what this gets us is VB project parse. We're parsing in a text, and we're using these scanfs, right? And so the order is very fixed right now. And we're going to change all that. Oh, goodness gracious. And then it tries to read in parse definition. It tries to make sure it read everything it could. And it's got to keep track of this offset and so on and so forth. So we're going to make this part better using the tokenizer that we just generated. That's the plan. So at that point, when paying the $3 to $5, you're not paying for the game, but for the interface to the game. Yeah, you're paying for the, like you said, the data that runs the engine. Cool. World War One. There was a couple of diesel punk games that came out not too long ago that were sort of in that had that aesthetic, with a World War One aesthetic. Oh darn. Okay. So for me, the tricky part now. Placing this. We're given text and a length. Read file reference text, copy text. We can set an optional size. Okay. In our case, this happens in main. Let's see here. has a more modern aesthetic, but it is in the time of World War One. Okay. Because of the modularity, I can make it possible to add different times. But gotta go eat. Be right back. So, sure. Have fun eating. Hopefully it's something good. Okay, so we kind of got a gut. This part here and this part here, basically. Let me think. Name, yeah. So these can all be tidied up later. Yeah, so basically all of this is going to go away in favor of what our new tokenizer is going to do. No, I lost power. Hopefully the stream comes back up. So we're going to hold on here for a minute. I'm going to reboot my camera. Hopefully the internet comes back up without too much trouble. Let's see. Camera. Plugs in there. Replug in the camera. Uh-oh. What's going on with my camera here? Sounded better? Okay. I think microphone is running. Oh, camera came back finally. Okay. Just waiting on the internet now. Ah. Wait for the internet. Okay, I think internet's back. Is the stream back? Okay. I think we're back on stream. Sorry, I've had a power flicker there. Let me make sure. Oh, pardon me. Yeah, I had a power flicker. Had to wait for the router to come back up. So sorry for the interruption. But here we go. Okay, instead of this. Okay. Sorry, things are coming back online after power off, so. So in theory, we parse our podge file name here, include the project parser. And when we parse, it is now file name. Okay. Ugh. One thing I want to do, if we look at test podge, you can see I have to do this work. Set the context, set the text, then process it lazily or not. I have to kind of wrap all this into some convenience functions and hide away the actual details. Okay, so context, blah, blah, blah. VB Proj Parser. So let's look at source VB project parser. It exposes our token class, which is great. That all is fine. We're okay with all of that. And then this is one of the things that's going to change in the future. This bvp.vtoke. No, not that one. This one. One thing will be single file cardinality. It'll be single or multi, right? For now, we assume single. That's going to be a thing. So in this case, what we want is to say After we generate the class for token, we want a thing. We want to say this. Process. And I want 3 different options for this because a context can read a file, reference text, or copy text. Process file. Process reference. Let's see, text reference. And sometimes we don't want to take ownership of text. We just want to text. Sometimes we do want to copy it and maintain our own ownership, but sometimes we don't. And this only matters if we're batch processing or if we are lazy. Let's go find lazy. So if we are lazy, we're going to do things a little bit differently. What else? What else? Basically, we're trying to turn this all into a couple of simple lines that we don't have to expose any of the underlying stuff, like the context or anything like that. Lazy. We can do things like error count. Log errors, log warnings. Tokenizer begin. Okay, except in this case, when we say begin, begin with a file. We begin with a text reference or a text copy. Has token token. One thing I want to do, actually not create all these copies if I can. If I can pass a reference out, that's better. But you do have to be careful because that reference could change underneath you. So if you want to keep it around, you should create your own copy, but otherwise we're not creating a copy. Basically, in this lazy processing, there's only one token that's ever instantiated and put on the stack or anywhere. It's up to you to create copies of that token as it keeps going. So I think that's it. Parser.cpp. This is not really exposed. You want to expose all of that and give it definition. These are just the convenience methods that we might like to have. Something I didn't anticipate we were ready for yet, but I think we're ready for it now. I think we are ready for better stuff. Okay, so if we go to, let's see here. We need a context and a tokenizer. Okay, process file, context. Nope, I forgot a thing. Const char star label. This is going to be important later. Actually, no. When you read a file, it labels it by the name of the file name. So that's fine. Reference text, copy text, buffer label, read file, file name. I think we just make one more hidden function here called process, which does this. Tokenizer set context. Tokenizer.process. That's it. Context.tokens. There we go. So that's what batch would look like. Begin file. Starts very much the same. Okay. Just adding that little bit of interface between me and the details. I think it'll be nicer for everybody. So we need to do that and that, basically. Set context, begin. Which really doesn't save me that much at all, but tokenizer.has token. Tokenizer.next token. That's basically it. Just simple pass through. But that should help things a lot. So we don't have to keep track of everything. And then I don't remember. I think context. I think we want this dependent on my logger. Log error, log warning. Oh. Well, a couple of different things we could do here. We do have log, but I don't think we want to leave this in here. Log error. Okay, well, maybe we do it that way. Maybe we just yeah. Okay. I think that simplified the usage a lot. We'll basically have our choice of how we want to process our file. And some simple wrapping around that. without exposing any details from the underlying structures. So you just say, here's a file, give me the tokens. Is that how I want to do this? In general, yes. Well, that's going to break a bunch of stuff. No, it won't break it. Project. Okay, so what we're doing is VB project parser. We have to know if we're doing this lazily or not. Do this differently though. We could do 4 VB project parser token in that or we could say begin file and while project parser has token we get our token equal to the project parser token. Then in here, we can process our token. Okay. So regardless of how we get the token, like this is a 3-liner instead of a 1-liner, but blah, blah, blah. Keyword encoding syntax file path. What is on the shell here? Oh, file path. So we don't want that. A through Z, A through Z. Followed by underscore A through Z, A through Z, 0 through 9. Star, I guess. Okay. So we want this to be name, not a file path. Do I want the colons? Do I need the colons? I don't think I do. So maybe we take syntax out. Test proj, whatever. So is this better? It's less typing. There's literally 2 things per line. Doesn't even have to be a line except. Yeah, okay. Do I want to allow white space in file names? I don't like white space in file names, but I know some people do that. Oof, okay. So main has been updated. So we're literally just in here, in the parse. A lot of our bookkeeping goes away. Encoding. Okay, so here's the deal. We kind of have different states that we need to be in. And we're going to say keyword, then name, then encoding. Oh, nope, encoding, then name. Name and file path are like the last ones. Okay, I think that's the precedence order. So basically, the word name and the word ASCII both meet this pattern. So does UTF-8 and token definition. So if this one's higher in the list, this is the one we'll get. If it matches this. So if it matches name, it won't ever get down to this one. So it won't ever record as name. And so we have to move the order around a little bit. This one takes precedence over this one. Takes precedence over this one. Okay. So bool. Or we could do this by like states. We could say state none is 0. State name, state encoding, tokenizer definition, and parser definition. We're going to start in state none. Switch state. So when we get a token, we say, what state are we in? Five. Name, encoding, tokenizer definition, parser definition. Okay. If we're in state none, then we really need token dot equals ID. There we go. So we just check. If token needs to equal keyword, do some work, otherwise it's an error. And this is not part of the tokenization process, so we're kind of in charge of our own error at this point. Okay, if we're in name, we expect token to be either a keyword, because a keyword can also be a valid name or name. bdp.vtoke, right? Or an encoding. Encoding would also be a valid one, huh? If we're in encoding, the only thing we would accept is one of these. Otherwise, do some stuff. And here we need a file or something. I forget what it's called. There we go. If it's a keyword, this tells us what state to jump to. Otherwise, we give ourselves a nice little error. Result equals false. Yep. Unexpected token. Let's see here. Who outputs the token? I guess that's VB prod. So VB prod parser, project parser token. I can get the line, the character, ID string, C string are probably the two I want, or log. Login context? There's so many options. It's all good. Unexpected token. I guess we do that. Expected a keyword. For now, that's good enough. This is not my favorite. Good enough for me for now. So encoding is probably the easiest one. A limited set of things. Whoa, no, don't do that. We set our encoding. Okay. So there's encoding. Okay, so m underscore name is easy. M underscore name equals token.cstring, and we get the reference. We don't have to do anything to it. So that's beautiful. This one's the weird one. This one, file path, kind of the same thing. This one. Let's see, where is it? There it is. Parse definition. All right, let's see, almost there. Token equals, this is one of the nice things, is we actually get to we've made our tokens pretty easy to compare to either the ID or the text itself. because of nice function overloads that we built and parameter overloading. If our token equals one of these options. File name, encoding, file path, file path. This all goes away. This all goes away. If result, that's fine. We don't need to do any of this. For now, we'll keep the text buffer parsing the same way it was. I don't think text is anything we even use anymore. So there, see, look at how this cleaned things up. Nice, simple, easy, and hopefully it works. We have to bring VVP this thing up to date. Oops, that one. And basically that happens. VVP.VVP, it's going to get a similar treatment. One thing remaining. If this was all valid, we set our encoding. Just because we've tokenized the thing does not mean that we are satisfied. If token equals, oh, that's better. Token equals okay, so it's encoding. We do that. Okay. What else? What else? I think this is much better. So all of this stuff where we're going from state to state, this is basically what a parser is going to do. Do I recognize this token? What do I expect to come after it? Check for those things. Tell people when they're wrong. So again, parser is not even that hard to write in some ways. The trick is precedence overload, operator precedence. But in this case, we have almost none. It's keyword value, period. And even then, the values are quite constrained. So I'm not too worried about most of that. We will replace this eventually, but we're not there yet. Okay, if the result is valid, coming out of the thing, to do check for required fields being present, etc. We could keep track. For example, the only one that we are even slightly worried about. Oh, and these ones actually. After we do that, state equals state none, whether we error or not. Is that true? I don't know. It might be that this just goes inside the valid path. For now, we'll just do this. Which actually simplifies. Oh, it doesn't simplify. I lied. Because of this one. Anyway. Where are we at? Is that? Do I think it's going to work? I have my doubts. I think we're going to have to fudge an older version at first. So I think we go back to VVPV2, no, VVPVVP. This one? Right now it expects these, which is a little bit unfortunate. That means we need like an intermediate thing here. Oh, let's see. If state is not equal to state none, and if our token equals syntax. Continue. So just skip over any colons we get. We can remove syntax later, which probably means that we do need it. Hey, On Climb, welcome aboard. Thanks for the follow. Hopefully you're enjoying yourself. We're building a compiler from scratch, doing it all the hard way, doing it the wrong way. In that, if you want to build a compiler for the sake of building a compiler, writing your own tokenizer is not hard. Writing your own parser really isn't that hard. It's a little tricky, but it's not too hard. But instead, we're writing a tokenizer generator, and we'll eventually get around to a parser generator. And not only are we writing a tokenizer generator, we're writing it in really bad ways if you want to get work done, but really good ways if you want to learn how the system works. Because we've got lots of choices we've made where we've taken both options, so we can compare later. Like the performance, we'll know how much using C++ iterator classes, how much that affects my performance overall against just iterating by hand, that sort of thing. So welcome aboard. Let me know if you have any questions. I just kind of code and talk stream of consciousness until somebody asks a question. So let me know. Otherwise, we are using our Tokenizer Generator to generate a tokenizer that will read in the configuration for our Tokenizer Generator. So we're getting very meta in here. Heyo, we'll be looking a bit. Cool. Never seen how the likes of Rec2 works. RE2C. Regular expressions to C. Okay. Well, we can look at some of that. So in 99% of cases, a modern regular expression engine is going to do a backtracking algorithm. We're doing something a little different. We're doing, let's see here, source pattern to NFA converter. We read our regular expression pattern in using probably not the best algorithm, but we're looking for special character classes, escaped characters, square brackets for character collections, etc., etc. And we're using what's called a Thompson NFA construction. So we scan through the whole thing, mark everything up, then we reduce it, and this is where we get our operator orders for our NFA. So escaped characters are special. They're the highest precedence. Then bracket expressions, grouping, cardinality. So 0 or more, 1 or more, or 0 or 1 of a thing. Concatenation, anchoring. So start of line, end of line, and alternation if you want to choose between two things. So we reduce things in a special order. That all seems to work out okay for us. I know that there's at least one bug we haven't crashed into yet, but we'll get to it. So we take our pattern, we reduce it to an NFA. So it's going to have like a tree-like structure. Then we take the NFA and we convert it to a DFA. So, and I have pictures we can talk about. You used flex and bison in college? Yeah. So we're writing our own flex differently. So they use backtracking algorithm. If you go look at a flex generated file, you won't see a strong state table. It'll be backtracking based. But what we do is we reduce our NFA to a DFA. So if you have questions about that, actually, let me just show a picture. It's probably worth a million words in this case. Active projects. We export this from our own test files. So this is a reasonable open with GIMP. Once that pops up, I'll share the screen. There we go. And then let me open the other one. That was the DFA. Let me open the NFA. Wait. And there we go. Okay, so this is our NFA. Let me share the screen. If I share GIMP. So this is an NFA for a test file that we're running. And as you can see, we support things like, this is a Cyrillic alphabet, so everything from capital A to lowercase ya. We support Greek right out of the gate, everything from uppercase alpha to lowercase omega. So we support UTF-8 in our regular expressions. Anywhere you see \s, wherever that is, here it is. We'll talk about this in a second because there's some interesting things here. Yeah, so this is the NFA version of a set of rules. we boil that down into a DFA. So instead of all those alternations, it literally says here in state 0, ask, is it a question mark? Is it a period? Is it an open bracket? Go to an accepting state. Here's new carriage return, white space, /. So this is for comment, right? // then everything until we hit an end of line character. Here's our English words. Here's our Cyrillic alphabet. There's our Greek alphabet. All that stuff. Here's an escape character with so quote. Here's a string basically. Is this state 814 until we hit the last quote, then we can accept. So yeah, so this is what we're building, and that generates code that looks like this. VB project parser. And we're doing this all wrong. Like, this is not something I would recommend most people do, but I want to ask the question, what if we dispatch our DFA states using a switch statement, or using a function pointer array, or using just a plain function pointer, or if we use gotos, right? All of those are options that we have. And then it just checks them. So this is not the same parse rules. Let's see if we can find state 0. Where did it go? So yeah, state 0 is a big complicated one. But it's just each of those lines in the DFA is this. Is the current character a new line? Is the current character a carriage return? Is the current character a space or a tab? Now this one is ASCII. If we go to a different one we've generated, test parser.cpp, and DSP. No, our last test was not. Anyway, shoot. This one. So if we generated our file using UTF-8 encoding, it would also check for non-breaking spaces, which is a thing I've run into multiple times with YAML parsers. They just blow up on a non-breaking space. We handle that if you choose the UTF-8 encoding. So we're doing some fun, interesting, unique things, I think. And we're going to just see how much we can do. Yeah, so we're writing our own flex, but it's going to be less flexible, but easier to use. And it's going to do some things that flex doesn't do. So that'll be fun. So there you go, brief overview. We'll put syntax back in here. Keep, colon, I guess. So in theory, we've started the bootstrapping process of using our own tokenizer generator to write our own tokenizer to bootstrap our next tokenizer generator. I think we're pretty close. So let's just try it. Let's clean. And that should rebuild the debug as well. Okay, a few errors. Good times. Oh, shoot. Yeah, there's an order to this thing. Okay. So what we want to do temporarily is stash the changes in VV project. Okay, we're doing this. We're going to temporarily stuff all of that into a scratch buffer. git restore DB project. There weren't a lot of changes here, so that should be fine. Is that true? Okay. DB source, DB project, HPP, still close, and CPP. So it should be back the way they were. Let's try that build again. So we're getting a little bit meta right now. We're just doing it because I think it's fun. Okay, we have to stash main as well. All right, let's try that one more time, see if that is good enough. Okay. Now whatever's in Scratch, put back in main. Back in VV project.h. Then back in VV project.cpp. Let me try this again. So let's see what was generated. VV project parser. Oh, darn it. Okay. Okay. One more stage to this. So we're going to restore UV project. This one. HPP and main. That really should have generated a new thing. Oh, it's not embedding that text. Oh. That's my problem. This code snippet wasn't being put in. Okay. Good. Now we go to main. PB project, HPP. And then CPP. Project parser. Darn it. Why is that not in there? There it is. It is in there. Okay. So these are now there. So now I can do the whole shooting match again. So when you bootstrap, you basically take something into parse your file. Then when you get something better, you use that to build itself. And you slowly iterate your way to where you're completely doing your own parsing. Let's see. bvproject.o parse undefined reference to this is inside the same namespace. Huh. bvproject parser.cpp. There it is. It was included. Interesting. Okay, process file. Home. Home. What are we doing here? Undefined reference to operator equals. Those are defined though. Let's see here. We did Oh, no, I think I know what's wrong. Objects. BB project. BB project parser is a thing we now need. We don't have a dependency on ourselves. There we go. Okay, that should define them all. That is true. Okay, well, we can fix that. Basically means all of this actually goes after that dot 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 right there. Which may not quite work. We may have to restash main and BB project, but we're getting closer. Piece by piece. Yeah, that's gonna not work well. Shoot. Okay. All right, we know how to do this. 1, 2, 3. BB project parser is not going to work. Therefore, we temporarily remove it from the list. Which might get us through our build stage here. That should not have built that. Yeah, so we're just trying to switch over to using our own stuff. Okay, so that worked. I put those back in. Put main back the way it was. Oops. Project.hpp. Then project.cpp. Okay. Now it may vector. What does it not know about vector at that point? Okay. I think I know why. I'm going to put pound include vector text. Okay, so I'll fix some of that. And vector. I'm not doing that, but you kind of have to if we're going to return potentially vectors. But we only have to do that if we're batch processing. There we go. I think that means I need to put main and VV project back the way they were, run everything again, put them back the way they are now, and then run everything again. This is the fun part, the back and forth. Okay. All right. One, two, three, 1, 3, 2, 3. Take this one out. Try that again. Yeah, so I took a college course on compilers, and we also used Flex and Bison. There were parts of it I thought were interesting back then, but I think we can do better. Oh, we forgot to do this. Like, the standard things I want to do in a tokenizer does not warrant me writing any custom code at all. So the fact that Flex kind of required it was a little bit sad. All right, try that again. Okay, so that worked. Now we put main back the way it was. Then project HPP, put back the way it was. If you have any questions about like NFAs or DFAs or what they mean or why we would use them or why we wouldn't use them, just let me know. Always happy to sidetrack to discuss the whys and wherefores and whatnot. Source VB project. Okay. Try it again. Oh, are you kidding? This stuff is still not defined. Oh, because of the make file, which we can fix. Should be a spec. C Films, hello, doing great. How you doing? I'm doing super good, super good. We are having fun playing with compilers, and that was shockingly good. Let's see here. Means we're getting useful output. Line 3. And line 3, it for some reason, what? Got very confused. When failing to parse this line. So, what's the compiler for? It will eventually be for a language of my own design. Probably a Algol-like, C-like language. I don't have any like sweeping grand ideas for new languages. But I do have some things I want to explore. Looping structures, branching structures. This is more of a building everything the wrong way so that we know why and how much and how everything works. If you want to write a compiler, you just write a tokenizer, right? It's not rocket science. You do a for loop, and depending on what character you get, you go to a different, parsing function. If you get a 0 through 9, you go to parse integer, and if you're in parse integer, when you get a dot, then you're like, oh, this is actually a float. Then you go to the parse float, right? So there's no reason to write a tokenizer generator, but we're doing it anyways because I like doing the NFA DFA thing, and we'll try some different explorations as we go through that. We'll upgrade in a little while our NFA DFA processing into a PDFA, so I push down finite automata, and do some unique things there that I don't think anybody's thought of. I think they're unique. So we're just building up pieces very, very slowly. This is like a once a week thing, so not a lot of momentum, just a way for me to break up the tasks and explore and have some fun. Not really a follow along. Like if I was going to do a follow along, here's how you build a compiler step by step. That would be a different series, a little bit more prepared. But yeah, we'll end up doing my own language. We may do an interpreted version and then replace that with like a transpile to C, replace that with a transpile to, not transpile, but compile to different assembly codes, maybe LLVM or maybe like WASM or FASM or NASM or something. And then eventually I want to write my own 2 raw binary, but we're not there yet. So we're parsing, we're trying to read this file, vvp .vvp, and it should be reading this. Heyo, C Films, thanks for rating. How is it going? Welcome, welcome. Always good to have a raid. The party of 1, that's like my streams. Cool. What do you stream usually? Ooh. And a follow. Nice. So, for those who are interested, should give a good old shout out to C Films, so people can follow and see what C Films works on. I actually kind of want to see what kinds of stuff you do. Let's see. Game development stream. Nice, nice. Oh, you're on the website side of things for now. Very good. Cool. Cool. I'll have to check out your stream, see what kind of projects you get up to. I'm not much of a web developer, but nice. Nice, nice. Very interesting. Cool. Well, welcome aboard. Welcome, welcome. Let me know if you have any questions. I just kind of stream and talk code, I code and talk stream of consciousness until people ask questions. Happy to dive into any level of detail anybody is interested in. But for now, this is vexing me. It's not understanding that this should all be together, and then that throws it off. It gets VVP, and it hits the dot, and it doesn't do the right thing. It's supposed to. Oh, ooh, we might have hit the bug finally. I knew this was coming. Good, good. Sometimes I talk about my other project, McFly. Okay. Let's see. So what's the McFly project? I don't see a link anywhere. Cool. C Films, is that the 6 Degrees of Seattle? McFly is a new math and statistics coding language developing in Python. Oh, cool. Cool. Nice. Coming up with a good programming language name is sometimes the hardest part. Python. Yeah, Python's pretty good for text processing in terms of not like speed. If you're looking to parse million-line projects, I wouldn't use Python, but yeah, 6 Degrees of Seattle. Okay. McFly, okay. Some Python, very nice. So read things by line and split for tokens. That's pretty, I've done a lot of special purpose languages in Python because it's just so simple to get started. Well, Neato, welcome aboard. Yeah, so right now we're in the building a tokenizer generator phase, and we have one, and it's way overbuilt. But we're trying to use it to parse our own stuff. And this part is making me sad. Therefore, what? Oops, I didn't want to do that. I'm going to go into our makefile, and we're going to here. We're going to see what's it called, main NND dash N dash D. So we're going to look at the NFA DFA for this thing. Oh, there's McFly. Okay. McFly. Hello world. So string literals plus minus multiply divide, easy enough. Comparison. Boolean string command. Okay. Pi tau e, very good. Okay. Cool. So if we go into McFly.py, take a look. Token type, yep. Lexer, advanced character, next. Yeah, this does indeed look like an actual programming language coming together. Very nice. Neato. It learns from the past but looks to the future. McFly. I like it. I like it. I've got my own programming language name ready to go, but I got to keep it secret so nobody steals it. Having a good name, that's tricky. Okay, so this time, did I? Oh, I do have. Here we go. I'm going to put these directives in here. Run it again. So we're going to output BBP vtoke, the DFA and NFA for this thing. And I think I know what's going on. Yep, there's the fail. Okay. So if we look at those, and they should be generated just now. Yeah. So let's look at the DFA. And then share the screen. Oh, that wasn't right. Got to open it in GIMP. For some reason, I can't share the default photos. 3. There's our DFA. That's not right. Wait a second. NFA, DFA, dot. Those were not newly outputted. Not. I should have. Let's see. Dash N dash D. So dash N dash D outputs the dot files, which we then have to compile out. Main. NFA dot dot. NFA dot DFA dot dot. Awkward. Okay, let's see here. I'm having trouble with taking the fly from the REPL stage to the next stage. Yeah? Using Python makes the REPL quite simple. But I guess it depends on what you think the next stage should be. So we can do this. If you want to go from an interpreted, well, if you want to go from REPL, let's see, let me go back to your GitHub page. Everything right now is line-based, right? McFly is inspired mostly by PHP and Python. Okay. Right. Dun, 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 dun. Examples. Okay. Okay. Yeah, so what you're doing right now is well, I mean, you've done it, Flex and Bison. You take your input text into your tokenizer, sometimes called a scanner or what else do they call it? Lexer. And that outputs a list of tokens. So like 1 plus 3, maybe. And then that goes into the parser. What comes out is an abstract syntax tree. So you'll have something that basically creates the relationship between the elements. And then you do semantic analysis, and this is probably where it's hardest to jump from interpreted to not interpreted, is going into this semantic analysis where you have to actually analyze. You say plus could be lots of different types, except in Python typing is hidden from you. But basically it figures out what the types of everything are. So if it knows that 1 is an integer and 3 is an integer, so let's do this. This is not the best format for this. Then plus has to be an integer if you add 2 integers, right? Or, you know, in case of one of these is a float, then the rules of the language by semantic analysis say that this has to be a float, right? So that you can cascade those types of tree to resolve those. So here, I want to be able to run more than 1 line of code at a time. I mean, I want to be able to run more than, yeah. So you have to read a file, process each line, and then you have to maintain a runtime. Let me see if you have assignment. Okay, so you need, right now you have no expressions that require state maintained between lines, from what I can see in your examples. So you have constants defined, but you don't have variables or assignment. But once you can process 1 line of code, then it's just iterating over lines and updating the state and executing each line. So you need to be able to store intermediate values. You're probably going to need to make a variable store. So that's going to be like a dictionary, where it's going to store a key and a value. And then, you know, assignment. So you need like an equals or an equals colon operator. But the fact that you've got single line expressions already running is good. So what I might do is something like for line in file, and I know that, you know, blah, 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 boilerplate. Evaluate line. And then basically the evaluate line function is what you currently do when somebody hits return, right? So def evaluate line does what you already have. Could you already do when the user hits enter, right? And then the only reason for multiple lines is so that you can maintain state between lines. So you'll probably want something like variables equals some store. So you already have some constants. So one thing you'll need to add is something like var name equals expression as an option. So you'll be looking for lines that contain this, and then take the left and the right. So maybe something like if line contains or matches the regular expression or whatever. I don't know. There's a million ways to do this. Equals variable operator expert equals line dot split on equals. Then maybe you evaluate your expression, and then vars sub var equals that result. Maybe. Right? So you have kind of this thing. If token is in vars, return the value. Something kind of like this, where you sort of recurse down from big, complicated expressions to smaller and simpler ones, maintaining your state for use in future lines. Then just for each line, you evaluate the line. In the line, you break it down into, here's my variable, here's an expression, we evaluate the expression, store the value, this sort of thing. I don't know if that helps at all. The end of the McFly code file is how code is ran. Okay, let me go dig into that one more time. Woo, 1,500 lines, not bad. Okay, while true, text equals input. Yep, tokens, generate tokens. Parser, you have a parser. Tree.parse. If not tree, continue interpreter. Visit tree. Print the tree, print the value. Okay. So you're there, except this while true input, right? You just do a with open file for each line in the file. Do exactly what you're doing. Lexer, generate tokens, parser, parse the tree, interpreter executes it, and then print out your outputs for every line in the file. Yeah. So you're actually really close. Just for each line in a file, do your thing. Tokenize, parse, and then interpret. Interpret the parse of the tokenize of the line. Yeah, you actually are very close. You should be able to do that. I think. Pretty fun, pretty fun. What was I doing? Oh. Okay, ND project file. And it won't parse it. Okay, so let's cheat. Let's cheat. VB project. We're gonna cheat. We're gonna force this thing to not fail, but we will accept for now. Now the name in this spot so I can show what's going on. And then vvp.vbp. No, let's put that back in there. All right, we'll allow a period. Still want to show what's going on. explain why this bug is occurring. We've been waiting for this to bite me for a long time. I've been sitting on this. I've been waiting for it. Knew we were going to run into it. Which means, oh, not vtoke. Oh. Okay. Oh, okay. So now it regenerated those files. Good. Look at this DFA. There we go. All right. So new lines. Oh, this is. Oh, that's not good. Still didn't output that? Okay. Right, I lied. We're not ready for GIMP yet. Because it failed. VVP, vtoke. We're gonna cheat. Name file and buffer. We're just gonna VVP dot vtoke. We're gonna take out the dot. See if that gets rid of the last error. I have an interesting, let's see here. I have an interesting way I want variables to be. I want all string variable names to start with a $sign. Yep. I want all number variables to start with a hash. Yep. I want all array variable names to start with an arroba. Very good. Okay. I mean, there's nothing stopping you from doing that. There's your tokenizer will have to handle that, right? And then as you process the line, you'll have to verify that the value you're stuffing in to a variable is the appropriate type by checking that first character. So that's your fundamental type checking. And like I said, with Python, number types are very fluid, so oh, it did. Okay, so here's our DFA in text format. Here's our NFA in table format. But neither of those is quite as useful as the PNG. So we open with GIMP. So let me close these old ones. This file. Okay, now we can share. I have to remember exactly the right order. Okay, there we are. So what's happening? Where's the dot? Dot. What is going on here? Oh, that's why. Okay. Okay, I think. Okay, so looking at this, we get any old letter, and it stays here for a while, and it can accept when it's done. That's not quite what we want. Because these letters, yeah, why is this not under here somewhere? I would actually expect this to show up down here where things happen. NAME ENCODING. See, these are the keywords. And there's this one. I should have taken the union of these though. And what it needs to do okay, so we definitely have a bug somewhere in our DFA building. So let's say that you go UTF-8, right? What if at F, we don't get the number 8, we get UTF-8 16, right? It should go here and say, we aren't one of these, but we could be one of these. Interesting. Let's see. Look at sexual. Hello. Oh, this is language of the gods level stuff. McFly will not be OOP focused. Okay, okay. Language of the gods level stuff. I don't know. There are some days when I think I'm terribly clever, and there's other days when I definitely regret my choices, which is, part of the fun. Do I have a favorite coding language I like to use? Locutus exul. Oh, Latin for spoken XL. That makes more sense. Yeah, I did not break that up in the right direction at all. I definitely had that S shifted over to the other word. Let's see here. Latin. Cogito, cogito, ergo cogito sum. And there are some great insults in Latin. Man. Favorite coding language. If I want speed, I tend to go for C, C++. I'm not like full-featured C++. I use a small subset of C++ that I care about. But there are things that C doesn't do well that requires I use some C++. If I want to just prototype something and do something fast and dirty, it's usually Python. Those are kind of my go-tos. All right, so we're going to come back to this. We're going to look at that bug. First, quick restroom break. I will be back in just a moment. Okay, we're back. We're back. Okay, let's see. Well, you are at the exact level of genius I need today, so I'm glad I found you. Oh dear. Oh dear. Well, hopefully I can be of service to you. You let me know what you need, what you have questions about, and we will take a look. And I don't know about genius, but you know, like I said, some days I feel clever, other days I regret my decisions, which I think is fairly normal for most people. Okay. So what should be happening is not quite happening. I'm learning, so right now mostly it's Googling how to code what I want, which functions to use for what I need. Okay, yeah. So what are you trying to code up? We are learning as well. We are doing all the wrong things for educational purposes. But if you need any help with like libraries or something, we're not using any. We have no dependencies, no libraries, nothing. It's all just base raw C, C++, standard libraries. That's it. And not even many of those. So I'd rather write the code myself. If I'm going to do something for fun and education, I'll write it myself. If I want to get a product out the door, then I use any of the dependencies to make my life more efficient. But we aren't there. Okay. Let me think. NFA, DFA. Okay, my dream is a 3D private server sandbox game with RPG elements, but I'm just trying to build an old school text RPG version of it first to show the engine. Yep, I'm going full open source because I want to make something people can use to do their own things with. Sounds good. Actually, let's see here. Suki in our chat. She's doing an open source strategy game, actually, RTS. So a good place to come. Sounds like a good project. Dravest, good afternoon. I am doing great this Friday. How are you doing? I've got some steaks waiting for me in the freezer. I'm gonna have to grill those up soon. I actually can't stream too late today. Gonna have to bail out a little early to get the steaks done on time. Locutus Exil. Old school text RPG. Yep, sounds like fun. Doing like a roguelike. Old Rogue used to be a text dungeon crawl, or you go in like full mud. The old oh, good heavens, my mind just went completely blank. But anyway. But yeah, building a small prototype is always a good start. So, okay, this is not quite the bug I thought we were going to run into yet. I thought we were going to run into something slightly different. Favorite game is Dungeons of Moria, so I say Moria like as a gist. There you go. There you go. Just got back from a Friday night drink with a friend. Good, good. Moria was the first roguelike. Okay. I did play old school Rogue a little bit on the Macintosh. There was a game called Dungeons of Doom. Hey, AC Films, thanks for the good luck. Always appreciate you dropping in. You have a good time, and yeah, have a good weekend. And drop in on Monday. We do game development on those days, Monday through Thursday. Compilers on Friday. Okay, well, Locutus, you let me know how I can help. I'm always happy to look at other people's projects. It's fun to see progress. Fun to Fun to give some suggestions. Thanks for the follow, Lucutus. Always good to have people joining in. So this bug is not what I thought it was going to be, so that's unfortunate. So what is it doing? Yeah, this is not the behavior I asked for. Any of those, or any of those, or any of those. But if at any point, so the DFA, going back to the DFA. I want McFly to have a lot of built-in functions. Yeah, yeah. For a math library, that's what you want, right? Everything exists, is ready, it's at your fingertips. You don't want to waste time redefining things that are common usage. So a lot of built-in functions. Makes sense. So let's see here. With GIMP. So here's the NFA. Here's the state for file name, or state for our project name, or it could be keywords. Keyword, 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 keyword. All these are the keyword starts. Like parse definition, toke definition, encoding on this one, name, but strangely, when we compile that into a DFA, it's not actually doing the right thing. UTLAPT. So there's two T's, TO and TF. Oh, ULAPTEN. We have no tokens that start with the same letter. So let's go manufacture one. Let's go manufacture a keyword for us. Custom functions will be declared with the keyword fun, of course. Of course it will. because function defining is fun. So let's look at a small thing here. Our keywords and our encodings all start with different letters, but now test and tokdef will start with the same letter. And let's see what that NFA DFA look like. So I think in my language, what I'm going to do is I'm going to actually define functions a little differently. It's kind of the way I see it is a function takes input and yields an output. And what you do in a C declaration, right? C style declaration is you say, here's the return type, name, and then parameters. So this is the input parameters, right? But if I want to read it, what I actually want, well, first of all, I want multiple return values. And I actually want input params, name, return params. So if you declare an anonymous lambda, it would be something like that. It maps these inputs to these outputs. That's how I want my language to work. Input, name, output. Which then leads to probably assignment is also left to right. So 3 into the integer x. But then multiple assignment can be a thing, right? So 3, 2, 1 into x, y, and z. Or z. So everything is read left to right. Those are some ideas I'm playing with. I do want it strongly typed. Yeah, there's just so many ideas to try. Did the build finish? It did. Okay, so if I reopen these files, open with, where's open with? Oh, good heavens. Let's look at the NFA, open with GIMP, and the DFA. 2, 3, okay. So T. So we have test, and we have tokdef. So state 43 and 31 are really the same state because they're looking for the letter T. So if we get a T, here's a T and here's a T. These should not be going to different states. This is not taking the union correctly. These should be the same state. And then depending on whether we get an O or an E, they should be different. Okay, interesting. When we take the union of those, which means that our code, what's in our code? Let me go show you the code. So what's being generated here in VB project parser, if we get T, go to 7, So what's in 7? O. Oh, let's see here. Are we not taking the closures correctly? This. Oh wait, let's see here. Reload. Search for T and T. So there are 2 T's in here. That's what I expected. 7 and 9. So one of these is test, one of them is token definition. Then our name and this one. Okay, so our closure is not right. Maybe we're not taking our closure correct. We're doing the NFA to DFA conversion. Because if we hit the end of the word test, which is, let's see here. So it's state 9 to state 20 to 28. We go to state 28. There's the last T in test. Go straight to 1. Otherwise, if we're done, we're done. Otherwise, unexpected character. And that's not right. Because you might just have a longer word that isn't the thing. Maybe we put like testing as a name. Okay. Are your variables going to be strongly, gradually, or weakly typed? They will be strongly typed. For performance, you can't be strongly typed. And the things I want to explore are kind of about performance related. Yeah, maybe not performance related, but I like to have the option to switch to high performance. I think that the not performant expressive language area is pretty full. I think that not enough people have cared about efficiency for a while. I mean, there's Odin, Zig, C, Jai. There are some now that are like, oh, we need to pay more attention to performance than we did, in Java, JavaScript, Python days. But yeah, I'll go strongly typed. Okay. So I'm missing something when I'm converting my NFA to a DFA. Yeah, it's one of the reasons I use Python for prototyping a new idea or learning a new idea, because then I don't worry too much about the types. But when you want performance, you know the types of everything. So then I switch over to C, C++. Okay, so I need to think about this for a minute. We are back in testing DFA, NFA to DFA conversions, because we can't proceed until this chart shows E or anything else going to here, right? So if we get PRS, D, and then anything that's not an E should actually just jump to here. And if this thing gets something that's not one of these, then it should jump to here, like, and try and go to this one. But that's not being shown. Or after F, the only thing that should be allowed is not more of this. Because these are basically subsets of this. It can be wrapped in more stuff. Nuts. Okay, so what did I do wrong in that then? Where in the process? Okay. That happens in the NFA to DFA converter. Compute closure. Find or create join to NFA state sets. Join two vectors. This might be useful. Join DFA debug. That might be worth pursuing. Go to make file. DFA debug. That'll output a lot of stuff. Okay. Here it is. Compute initial state given NFA 72. '69, yeah. This isn't more readable with the NFA graph up next to me. But basically, this is gathering a closure. That's our initial state. So basically, we're adding NFA state 1, 2, 0, 1, 2, 5, 7, 8. We're adding these states to what will, in the shortly future, be the DFA state. Transitions. Closure, nothing to do. Find or create. Can accept. N. RT /:N E T P T. Uh-oh. There's our two T's. Two T's. Hmm. So we need to ask, was there already an overlap? Closure given NFA state 38. Hmm. T and T. Let's see here. To do. So here's kind of what happens. Let's go back to this thing. In the NFA, you don't know. You have to try both roads, right? So you might say this is or this thing or this thing. And this thing is either this thing or this thing. So we just have to test them all. And what a DFA does, so this is non-deterministic. We don't know. We have to try both paths and find out which one it is. And in deterministic, we say, well, this could be either this or this. And this could be either this or this. So it actually just wraps up everywhere you can get to from here, like this, into one place, like that. All of that's called the first closure. So closure is basically everywhere I can get from here. So when we consider this state, that's all the things we can get to is along the line above this that I'm sketching. Something like that. But somewhere along the line, it's not detecting that this T and this T, we can't distinguish between these two. And we don't know that TES, if it's not T, would have to jump here. Or if it's TEST and something else would go here. So we've done something wrong. I don't know what it is yet. Because both of these T's should not generate this state and this state. It should generate one state, and then only on getting an O or an E do we know which way to go. And if we get something that's not an O or an E, it should jump over to here. So one of the ways we're combining things is not right. And unfortunately, this part of the code was something we worked on some months ago. So I have to think. Join. Computed closure. thought we'd end up in this collision area. That doesn't seem to be the problem. So we say take this NFA, and compute our DFA states. We start with a temporary NFA closure. We add the start state, compute this closure. Then we either find or create this thing. That's our initial state. Process a new DFA state. Process new DFA state, blah, state count equals 0. Preloop. So before the loop, we make sure that things are valid. For each DFA state. If it was visited, continue. What if we don't do this? How bad is that? What if it's not finding those overlapping concerns because we've already zeroed it out? Or does it go forever? Yeah, this is going too long. Yeah, it should not be doing so long. Closure. Our NFA state is terminal, so not an or, basically. Unprocessed. Push back. And FA state and the closure. We we move those out of unprocessed. Bum, bum, ba-dum. See, when we get to NRT NET, and here's the other T. Okay. So when we add a DFA transition, there are two cases. Is that correct? One is if they're equivalent. One is if they are, one is a proper subset of the other, or even not a proper subset, any overlap of the other one. If they are equivalent, then our next DFA state is already set, and we add the thing to the other closure. See, I copied this code from another place where I'd written this out before. In Python. Was it Python? No, I had parts of this in C. So I stole this from an old sandbox project. If there is overlap between two things, two transitions check the same value, we must create a new state, which is the union of those two. I remember having to do that before. Don't think that's the culprit there. Find or create. DFA states. Start state, computer closure. Ugh. I'm probably not gonna get this solved today. Shoot! Not the way things are going. Start state, compute the closure. I'm reasonably sure that that closure looks fine. So compute initial state done. Is this. And it contains 0, 5, 1, 2, which I can verify this NFA. One, two, five, zero. It really said 0. 8, 7, 13. There's 13. Where would 7? Zero and 7. Does that mean 12 also got in here? Yeah, 12, 13. 16, probably a 47. What's here? NFA state 72 is that one. So 69, 70, agreed. 69 drags in 65, 66. 60, what's here? 70. It's already been added. There's nothing to go from there. 47, 48. Which will drag in 66. Yeah. 14, 15. Agreed. 16, 13, 49, 61. Yep. 50, 55. Yep. 14 brings in 12 and 13. Yep. 48, 49, 61. Where's 48? 49, 61. Yep. And then 50, 55. Yep. Gets 12 and 13. Yep. 15, 16, 43. 15, 16, 43. 16 gets 17, 31. 37. 18, 31. And then 19, 23. Agree. 7, 8. Agreed. Then 0, 5, 9. 0, 5, 1, 2. Eight, 0, 5, 2. Okay, so that initial closure is correct. This down to here, completely correct. Agreed, 100%. Compute DFA states. Begin. Initialize transitions. Sure. Finalize DFA state. This is where we actually go through this closure and gather everything up. We make sure the closure is complete. We find or create an actual DFA state, which can accept. Inclusion. Add the DFA transition. Next, closure begin. 3 and 4. NFA 3 and 4. So that's the new line. Done. On a \r, we get 6 and 5. Yep. Tab just goes to 9. /:: T and T. I agree with the existence of these. So part 1 is when we add DFA transition, we have to add this. Oh, so let's see here. Here we go. This one created a closure 38, which is the start of the next thing. And this one, when it hits T, it adds a state 51 to its closure. So what it needs to do is say if these two are equal, with the inclusion T and inclusion T, then we add this state to this one, and then recompute the closure of this thing. So we don't add a new DFA for T twice. We only add it once. Then when we get down to these ones, these also include T, right? So this should also be added to those ones. If inclusion add DFA transition. Okay, I think I know what to do. Although I'm not sure if I really like it. I don't think we have time to build and test it. Add DFA transition. It's this piece right here. Where we compute that closure. Next. Whereupon we compute a closure. This next DFA state I'm not sure. I'm not sure. This is just testing if we can accept closure and identifier transition in processed. Okay, and if this occlusion overlaps any other occlusion in the DFA state, next DFA state, find or create, oh, jeepers. So I'm going to take this closure next DFA state, remove it, all right. This is not what I had planned for today, and I had a short day, so I don't think we're going to finish this. Basically, you take a closure, you go through each thing in the closure, you say, what letters are you testing for? Then you add that to the transitions table, and then once you've found a transition, you compute the next thing it could go to, and either look it up or create it, depending. And then that becomes the start of your next state that you would transition to. However, somewhere between there and here, DFA state transition, find or create. What does that even do? Oh, jeez. So we added a closure. If index is less than keys, oh, right, so we didn't get all the way through. Done. Otherwise, we didn't find, and we must create a new DFA state. Where is closure keys? Push back our closure. So we find or create yeah, this is going to be a problem. All right, I've got to wrap it up for the day. This is a stickier problem than I was planning to tackle on a short day, but we are running into it, so we'll have to fix it next week. And I'm basically reloading old code into my memory, which that work will basically be lost over the week. So we'll see how it go next Friday. But yeah, Monday through Thursday game development, compilers on Friday. Let me know if you have any questions, comments, concerns, and we will be picking up there next week. So you have a wonderful, wonderful weekend, and we'll see you next week. Bye-bye.